Hello everyone, welcome to CodeChef. Myself Jwala Chaurasi, and today we are going to solve a problem which came into start as 212. The name of the problem is P2BAR and the problem code is signal. The difficulty rating of the problem is cakewalk and the prerequisite is ad hoc. Let's start with reading the problem statement over here. So guys, problem says a secret binary transmission is represented by a string S of length n. In this signal, 0 represents a silence period, 1 represents a pulse period. Your task is to determine how many pulses occur after at least one silence had already appeared in the transmission. Input format. The first line of input will contain a single integer t denoting the number of test cases. Each test case consists of two lines. The first line contains an integer n, the length of the binary string. The second line contains the binary string s. Output format for each test case output on a new line. The number of pulses occurred after at least one silence had already appeared in the transmission. Constraint for t lies from 1 to 10 to the power 4, for n lies from 1 to 10. The sum of n overall test cases won't exceed 2 into 10 to the power 4. So guys, now let's understand the sample test case in the question more precisely over here. So guys, this question is pretty much straightforward. It says a secret binary transmission is represented by a string s of length n. And in the signal, that is in the string, 0 represents a silence period, 1 represents a pulse period. So our task is to determine how many pulse occurred after at least one silence, that is after at least 1 0. Okay, so let's take the first test case. So this is our first test case, 0 1 1. Okay, so in the test case, so let's say this is a test case 0 1 1. Okay, and we can say that in this test case, for the first test case, period 1 is a silence period. Okay, so that means there's 0. If I do this, then you can see that this is 0. That means it's a silence period, right? So after one silence period, there is two pulse period, that is 1 and this one. So output for the test case would be simply equal to 2, right? And you can see over here our output is right. Okay, so guys, I think the test case is pretty much clear. Now let's move toward the simple solution. Suppose the first silence appears at time t, then every pulse that appears after t is valid, while every pulse that appears before t is invalid. So it's important for us to find the value of t. This is simple. Just iterate through the s, that is a string. Check for the leftmost I such that s of I equal to 0. This becomes t. Once t is known, the answer is the number of pulses after t. This is again simple. We will iterate through s starting from index t plus 1 and then add 1 to the answer if s of y equal to 1, right? So this simple simulation solution, guys. Now let's move toward the simple C++ code for this question over here. So guys, this is my simple C++ code. I took the input for all the test cases as well as n as well as for my string s. I initialized answer equal to 0 and integer flag equal to 0. I ran a for loop and check if s of I equal to 0. I initialize flag equal to 1. Else in the case I will add up to the answer, and at the last I will simply print answer. And as you can see that, guys, I have got my C++ code, right? And let's move toward the Python code. So guys, this is my similar Python code. I took the input for all the test cases as well as n and s. I initialize answer and flag both to 0. I'm running a for loop over here and then checking if s of I equal to 0, I will make flag equal to 1. In all the other case, that is for the pulse, I will add it to my answer. Yeah, and you can see that my Python code is as well as right. So guys, I think the solution, the code and the approach is pretty much clear. Now let's meet in the next video. Thank you so much guys for watching our videos.